In this video, I will be solving the last problem of AP-1 section, that is common2. Here comes the 5 seconds break for you to pause and attempt this problem on your own. Alright, let's read the problem statement. Start with two arrays of strings A and B, each in alphabetical order, possibly with duplicates. Return the count of number of strings which appear in both of the arrays. The best linear solution makes a single pass over both arrays, taking advantage of the fact that they are in alphabetical order. So in the common2 method, we will be given two string arrays A and B, and we need to return back the count of the number of strings that appear in both of the arrays. And it has also been mentioned that in any of the array, there is a possibility of duplicate element also. So if we analyze the example 1, here the result is 2 because C appears in both of the arrays and X appears in both of the arrays. So the result is 2. If we see second example, here A is coming in both of the arrays, C is coming in both of the arrays, and finally X is coming in both of the arrays. And for example 3, all three elements are equivalent, hence the result is 3. So now how can we solve it? First of all, we need to handle the duplicacy case. For example, suppose if array A contains A multiple times, something like this. So obviously we won't be counting this multiple times. We need to start counting from the last element, and same logic applies on array B as well. So first of all, we need to traverse both of the arrays till the last unique element, and as usual we will be defining two pointers, int I equal to 0, j equal to 0. I will be used to keep track of array A while j will be used to keep a track of array B. And also we need to define a third variable result, which will be holding our final result or the number of common elements. So now we start traversing while I is less than a dot length and j is less than b dot length. So as we discussed, first of all we need to traverse both of the arrays until we find the unique or non-repeating element, for which we can write if I is greater than 0, and we are comparing these two simultaneous elements at a single time, and a of I is equals a of I minus 1, that is the previous element. If this is the case, like this, so we need to increase the I pointer. Initially I was pointing to this, now I will be pointing to this, and also continue to skip this iteration and continue the work from next iteration. Once this will be done, we will be reaching at the or pointing the last element which is unique. Similarly, we can write this for array B as well. Same logic. B of j equals B of j minus 1. In this case, we need to increment j pointer and continue. Now we actually go and check whether a of I is equal to B of j. If that's the case, for example C and C, if that's the case, then we need to increment the result by 1, and we also need to increment both of the pointers I plus plus and j plus plus. But it's also a possibility, else if, that this particular element or a of I comes before b of j. which we can write a of I dot compare to. We have seen the working of compare to in our previous video as well. Compare to b of j. This method returns a negative value if this first operand comes before the second operand. So if we find that a of I comes before b of j, then obviously we need to increment this I pointer by 1, because a and b are not equal. So we need to increment this and start checking the next element in array A. Else we can go ahead and increment j pointer by 1. If we find here it's C and here it's B. So in this case we need to increment this pointer by 1 to check the next element from array B. And like this it will keep on executing. Let me remove the extra lines. And at the end we can finally return back the result. So this is the entire code, entire logic. Let's copy it in IDE and run the test cases to verify the logic. All of the test cases are passing. Now let me submit this code on portal. I always copy one extra brace. Yes, all correct. And finally push this code to GitHub. With this we have completed solving all the problems of AP1 section as well. And from next video onwards we are gonna start solving problems of some other section.